In this video, you will see how to convert the complex diagram. We know that the Python automator can be defined as m equal to q comma sigma and stack symbol where the q naught is at mf, but q is the set of states and sigma is the symbols and state symbols as well as that's the transition state. And q is the initial state, z is the top of the stack, and is the set of final states. Similarly, we know that the grammar can be defined as the context-free grammar can be defined as G equal to V, P, P, S, and P. If the context-free grammar is given, then how it can be converted to Python automator, that we will see here. We are going to convert the context-free grammar to automator with empty stack. After the transformation, we get the empty stack. When we are converting, Q is the second stage that's different functions, and T, where sigma is the input symbols, all the terminal symbols are considered as the input symbols. So when you are processing, consider all the input symbols as the terminal symbols. So we know that when we have sigma is equal to T. Similarly, the next is the variables. Your tape symbols in the tape, you can use the combination of variables as well as the terminal. So the tape symbol is the combination of V union, that is the union of variables as well as the terminals. We know that the S is the starting symbol in this stack. You can push the starting symbol also. So we are considering that Z equal to S. When we are converting the given productions into a Python automata, the terminals are considered as the input symbols of the Python automata, and variable union terminals are considered as the stack symbols of the Python automata, wave symbols of the Python automata, and the starting symbol is considered as the top of the stack. Again, here we are following two rules. First one is for each variables. If the variables in the form of A tends to beta, then we can write the transitions for Python automata like this one. Delta of q comma epsilon comma left hand side A tends to q comma right hand side. Okay, A tends to beta implies q comma epsilon comma A equal to q comma beta. This is the first step. For all productions, we should write this one. And for all the input symbols, that is for all the terminal symbols, we should include the root q comma. Suppose A is the terminal, then we should write q comma A equal to q comma epsilon. That is also another rule. We are following two rules to construct a Python automata from the context-free grammar. Consider this example where context-free grammar with production says tends to 0s1 00/1. We should follow two rules. The first one is A tends to beta. Here it's like this one, S tends to 0s1. So it can be written as q comma epsilon comma. What is there in the left hand side? Yes, equal to q comma. Instead of S, it's written as 0s1. So we write 0s1. That should be written in the right hand side. That is for S tends to 0s1. Similar way, write it for S tends to 0 and S tends to 1 also. So S tends to 0 for this one, this is applicable. Then for S tends to 0 delta of q comma epsilon comma is equal to q comma 0 and delta of q comma epsilon comma is equal to q comma 1. Right hand side there are three productions, so then the three transition functions. Additionally, what are the input symbols are the terminals? 0 and 1 are the terminals. So here I am writing as productions for 0 as well as 1. For 0, 2 comma 0 comma 0 equal to 2 comma epsilon, and for the 1, 2 comma 1 comma 1 equal to 2 comma epsilon. Now I can write a Python automata m equal to q. What are the states here? Q comma sigma. What are the input symbols? 0 comma 1, right? So I can write 0 comma 1 is the input symbol. What are the variables as well as unions? The terminals are 0, 1 and the variable is S. So I can write the tape symbol as 0 comma 1 comma S and transition function. Then Q naught is here. Q is the initial state as well as the final state. And what is the top of the stack? The starting symbol S is the top of the stack. Final state is also Q. So this is the required Python automata, and these are the transitions of the Python automata. We can design one more push-down automata. For example, consider push-down automata with productions S tends to ABB and A tends to AA. If I am going to design a push-down automata for this given productions, in this production, what are all the variables? Yes, A, B are the variables, and what are the terminals? Only A is the terminal. So I should try the transitions like this one, and write delta of S tends to. So A tends to beta like this one. So I can write 2 comma epsilon comma left hand side is S. Okay, that is equal to 2 comma. What is there in the right hand side? ABB. So it can be replaced by ABB. That's the meaning of that. That's the first transition. And when you go to the second transition, A tends to B. So I can write delta of 2 comma, same epsilon comma A. It can be replaced by AA. This is for these two variables. Again, check the terminal. What's the terminal symbol I will do here? A is the terminal symbol. For that one also write the transition in comma A comma A into 2 comma epsilon. Here also only one step is there. This is the transition of the push-down automata with empty stack. We can convert the given context free grammar into push-down automata with the empty stack. Now we can define the push-down automata. What are the states? There is only one state. What is that state? Do not. So the state is do, comma, input symbol. What are the input symbols here? The terminals of the input symbol. Here there is only one terminal here. That is the input symbol. And the tail symbols, variables as well as the terminal. Here what are the variables? Yes, A, B are the variables and A. So these are the possible tail symbols. And delta is the transitions that's given over here. And what is the initial state? Q. And the final state is also Q. And top of the stack is there are three variables, but S is the starting symbol, and S is the top of the stack, and Q is the final state. So this is the required push-down automata. So every context-free grammar can be converted into a push-down automata with empty stack. That's all. Thank you.